Thank you very much. I appreciate your taking the time today. This is a fairly complicated topic. We're going to be trying to marry two different disciplines here. We're talking about zero trust, which is an evolution of a set of concepts that have been around in IT security going back to the 90s, with some issues that arise from the continuing integration of IT capabilities into industrial control systems. The abbreviation OT, for operational technology, was not created by anybody in the field. The people who are doing SCADA or HMIs do not think of themselves as being work in OT. That's a conceptual level that was put around it for the convenience of folks looking at it from the outside. So what we're going to do today is talk about what zero trust concepts can and cannot be brought into the OT space. So, a disclaimer. And this is what we're going to talk about. Recent attacks. I'm not going to go through details on the attacks. We've already burned 5 minutes of our time. We're going to talk a little bit about what zero trust is, then we're going to get into the integration points with industrial Internet of Things. One of the key charts, if I had to give a 5-minute version of this presentation, one of the two key charts I'd use would be the one that talks about applying process hazard analysis, which is a chemical engineering discipline, to engineering disciplines generally, and augment it to call it cyber process hazard analysis. So that's, if you need to get a thumbnail version of what this was about, that's one of the two key points. Next, we're going to talk about some things that zero trust cannot do, and these fall into three general categories. One is the technical stuff, the second is the organizational stuff, and the third is the architectural stuff. And I'll hit those a couple of times in the course of it. I've got some things to ask vendors before we get to the end, the obligatory what we learned slide, and I always include references. So the stuff that's here is documented from what I believe to be reliable sources, and anybody who wants a copy of the material can certainly get it off the website or contact me, William Malik TM on Twitter. So vulnerabilities in ICS. It's not picking up the content. Okay, so the general problem is we're putting more and more IT into our factories, and as a result, we're creating greater attack surfaces. Whether you do software testing or threat hunting or physical analysis of vulnerabilities and consequences of interruptions, you know that the edges are where the bugs live. So you want to watch out every time you introduce another dimension to your technical portfolio. You've got another edge, another surface that's of the area of a vulnerability. So we put smart stuff. Nobody would ever think that someone would do something to cause problems in this, but people do it. And it used to be just to show off, and then it was for money, and now we're seeing this as an aspect of nation-state activities. The number of advisories coming out of the ICS CERT has grown dramatically over the last few years. This is just a consequence of the increasing utilization of these things and the fact that we're now actually seeing these problems and recognizing them. In fact, I just saw an article last week in The Guardian that talked about how everybody's concerned that the smart meters that are being used for home electricity consumption turn out not to be so smart after all. And with the last 30 years of my professional training, I thought, oh my goodness, somebody's hacked the smart grid in the UK. Not a word about that. Just about, the problems with upgrades, and there's so many out there, and nobody really is skilled at handling this stuff, and that's a recipe for disaster, because that's a way to disrupt an organization. Take over the smart meters and have them all indicate a spike in demand, right? That'll bring your grid down. And you don't even have to get anywhere near a substation. So vulnerabilities, these all have been noteworthy ones from history. The Saudi oil refinery attack where they disabled safety systems, the Stuxnet attacks, of course. WannaCry hit Boeing, that was 3, 4, 5 years ago, and so on. And then more recently, these are just attacks that came out in the last first quarter this year. Rockwell Automation, Schneider, Siemens, GE, Toyota. They've all had problems that have damaged their industrial control systems with significant consequences for the users. We're even seeing worms invade the environment. The Morris worm crossed multiple boundaries. Never got into IBM, by the way. I was working there at the time. Because IBM didn't have that kind of internet connectivity. It was all mainframes. Didn't happen there. Apples get mainframes. ZEOS doesn't. Apples get viruses and worms. ZEOS doesn't get viruses. Anyway, the fact is that these kinds of problems are out there, and you're putting in a new platform, new generation of hosts. Those of you who recall the TSMC environment, they had 100,000 robots to make chips. Somebody went onto the floor to do diagnostic information. They plugged their laptop into one of the robots and unwittingly introduced a virus onto the robot. Now, the robot was running a vanilla copy of Windows 7. So the virus took hold and spread rapidly. It knocked out 100,000 robots in 40 seconds. You could see it happening. Flat network, right? But why the heck would you run Windows 7 in, this day and age? And the answer is because that's the way the vendor made it. And if you break the seal to upgrade the software, you void the warranty. Same problem applies to medical devices. In the US, they go through FDA approval. The approval cycle takes 5 to 7 years. So when you're in the OR, the machines that are monitoring you are, Windows 98, Windows XP, maybe Windows 7 if they've gone through, but they can't upgrade them. They'll lose the certification. So when you look at the industrial environment and ask, where are my pictures? What you see here are the things in orange. Orange are, have interesting shapes, and those are industrial devices, and they're subject to attack. And the things that are boring blue rectangles are IT platforms, and they are also subject to attack. There's no safe place. This chart is from a report that Trend published a year ago, I believe. So we even see attacks against automation software. The issue here is that these products have their own languages. Now, the languages are fairly familiar. If you're comfortable with C or with Python, you can figure out your way to program some of these things. And if you program in C or Python, there are static analysis tools that you can use to detect problems. The issue here is the install base. Each of these languages customized to the individual manufacturer. So they don't have tens of millions of users, which means if you are a vendor of a software validation tool, you are not going to spend resource updating your tool to support any of these guys because there's just no money in it, right? So you don't have static analysis tools, and these are powerful languages. They can do call by name, which means you can go indirect, you can pick a variable off of the internet, you can publish stuff to the internet, and we've talked about this, also Trend has published a report on that, on the vulnerabilities of robotic software automation. This is a current link. I'm going to see if this works. Didn't ask permission about this one. We'll see if I can bring this up. Okay, this is a company down in Brazil, I believe, and this is a live feed of open IT incidents that they've got, starting with the 19th of May and going back to the 5th of January. And as you see, this is just the first page, and there's many. You're not seeing anything? Oh, okay. Never mind. Yeah, just go to that URL. What they have is a link, and it's got active current information. If you've got internet connectivity, you can browse over to them, and what you'll see is, dozens and dozens of incidents, report updated daily. So, lots of problems in the industrial area. So, brief introduction to Zero Trust. Very simple, very flat. The idea is the cloud has no perimeter. We're not going to presume the trust of anyone based on the fact that they got to a certain location. You have to prove who you are. Okay? It is the opposite of the theory of jurisprudence in this nation. You are presumed guilty. You got to prove you are who you say you are before you get access to anything. There is a source of trust, and you have to go through a regimen to get there. We are going to ask you to authenticate yourself based on risk. We're going to ask you to authenticate yourself robustly, multi-factor authentication. I'm going to establish separation of duties. We've got a few other things that make up zero trust. In the late 1990s, there was a concept called NAC, Network Access Control. Georgia Tech uses it on their on-site Wi-Fi. Anybody can connect to the Wi-Fi, but you can't log on unless you've got a valid logon. And beyond that, when they attempt to connect you, they're going to take a look at your machine. Do you have current software? Do you have current anti-malware? Have you run a scan recently? Are you missing any updates? And oh, by the way, who are you? Have we seen that ID showing up with malware? Has there been odd activity? If any of those things are a problem, you're going to be routed to an anteroom to get that fixed before you can get onto the network. NAC is a component of zero trust. Your behavior, user and entity behavior analysis is a part of a zero trust as well. We want to verify your identity. We want to make sure that you're limited in your scope. If the folks at TSMC had put in 100 firewalls, they would have lost 1% of their capacity, not 100%. And they would not have been down for a week. And that would not have hit the GDP of Taiwan as a result of that outage. Default deny. Think of it as in the mainframe world, RAC FUAC none. You can't do anything until you've got an explicit permission. And we make sure that you are who you say you are. So zero trust risk insights is going to take a look at your behavior. We're going to take a look at the network. We're going to take a look at your device. And we're going to ask you to prove you are who you say you are. When you get there, now SASE, Secure Access Service Edge, is simply applying zero trust to cloud. Okay, so zero trust is the larger thing. SASE is a productized version for a specific environment. Going beyond VPN, I do have a VPN on my laptop. I use it for one task, and that is updating my password. Every application I go through unique authentication, standard way of proving myself, multi-factor. Not a big fan of VPNs, but if you have nothing, there's something. Now here's the first of the important charts. Pictures. I need to say the right spell for pictures. Cyber process hazard analysis is applying a discipline from chemical engineering. The framework of it says that I'm going to take a look at what can go wrong and what are the consequences if it goes wrong. I'm going to design around that. I'm going to operate and maintain the system so that I preserve the two mandates of industrial environments. The two mandates of industrial environments are, first of all, the reliability of the underlying service, and the second one is the safety of the people and the environment in which that thing's working. The example I like to tell when it comes to talking about safety and reliability in physical systems is think about an escalator. If you're on an escalator out here and it breaks, what's going to happen? I'll tell you exactly what's going to happen. It's going to come to a stop and lock in place. You're not going to be totally down. I would tell you that was intentional to keep people's attention, but you wouldn't believe me. So it won't fall apart. It'll lock in place. And guess what? It's still useful. It's a stairway. You can still walk up the stairs even though they're not moving any longer. That's really good industrial design. That is very different from the mandate for IT. The IT mandate is information shall not be lost, altered, or inadvertently disclosed. We call it confidentiality, integrity, and availability. That acronym is complex, big words. When you're talking to non-IT folks, you want to say we don't want to lose data, we don't want it to be changed, and we don't want people who shouldn't be able to see it to see it. Those two mandates are orthogonal. You do not solve the problem of the underlying reliability of the system, the service, if you're worried about things like the availability of the data. Those are different terms, different disciplines behind them. That's one of the areas where the intersection between IT and OT is so difficult to cross. So when you take a look at a physical system, you have to ask all of the things that can go wrong, and what, first of all, the likelihood, and it's simple, it's low, medium, or high, and what are the consequences? Again, simple, low, medium, or high. Don't waste time with quantification, you'll make yourself look foolish, right? If you try to get to the second decimal on what the cost of a very small event causing a very large impact, well, I studied math once upon a time. And when you're dealing with measurements, estimates, you have to be aware of precision. When you have a very small likelihood number that is an estimate and a very large potential consequence, which is an estimate, and you multiply those two numbers together, you have 0 significant digits left. You cannot perform that calculation, right? That's just how the math works. You can't do it. So don't attempt it. Do instead a much more pragmatic thing. Low, medium, or high chance, low, medium, or high consequences. You've got 9 boxes. The 3 in the upper right-hand corner you worry about. The 3 in the bottom left you don't worry about. Okay? That's how you prioritize your risk management measures. Very simple way. I should have made a chart of that, but the deck is already too large. Applying cyber to that means you have to start thinking like a physical engineer, not a IT person. We don't say, oh, you're going to have to reboot. Not with my pacemaker, not with my hydroelectric power plant, thank you very much. Continuous operation of the underlying service. Now, I have to make sure it's there. There is a commonplace that says the bad guys only have to get one thing right to win, whereas the good guys have to get everything right or they lose. Well, that's not actually true, right? According to the cyber kill chain folks at Lockheed Martin came up with, they said the bad guys have to get about 7 things right to win. If you can interrupt them anywhere along that path, they fail. You win. So break down what it is they have to do to get there. You don't have to do it by yourself. MITRE's attack framework will do it for you. That'll show you what kinds of things can happen and how they would go forward. Okay? Where do we see applications of this? The CISA has come up with a set of recommendations on how to defend against this. Now, are we going to get to the second part? That's it. Okay. Yeah, we reduce risk of infection so the problem doesn't start. We minimize the impact so as soon as it does happen, we can cut the costs over time. The less likelihood they have of succeeding up front, happier things are, the faster you can recover, the happier things stay. Again, network segmentation, 100 firewalls saves 99% of the capacity. There's another commonplace in IT that I'm going to get on the soapbox about, and that is that users are the weak link. That's not true. Users are the strongest link, and I will carry you through an example. Imagine an employee at your firm who is not an IT person, and they're walking down the hall and they see someone doing something wrong online. I want you to ask her 3 questions. First of all, would she know if it's wrong or not? Second of all, would she choose to report it? And third, if she picked up the phone, would she know who to call, right? If she knows what's right or wrong, that means your awareness program is okay. If she decides she's going to report it, that means your culture is okay. And if when she picks up the phone, she knows who to call, that means you've got the mechanisms to reinforce that culture in place. If you have the culture right and an underlying set of good awareness measures and the mechanism to support it, you win. They will make it work to keep you safe. But if nobody really knows what's right or wrong, or she sees something and goes to her boss, and the boss says, well, yes, you're right, that is a problem, but that's not our area, so we really shouldn't get involved, right? Ever had that conversation? You know, or they pick up the phone and they call the help desk and say, I think there's a security problem. They say, transferring you to security, right? So you get a security person and the guard wants to know where the fire is, right? Well, you're sunk. And it's not the person's fault. It's your procedures that are at fault. People are the strongest link. You've got to give them the tools and try to guide them away from making the bad mistakes. More detailed examination. This is from the ICS SCADA group at SANS class on security essentials. The details on this chart tell you what you need to do for local, for large, and for host-centered environments about where to put sensors, where to put firewalls. You want to break things up into segments. You want to minimize the amount of activity. You want to strip out capabilities that are not necessary. Nobody needs to run a compiler in an industrial factory. You don't need to do that stuff. You don't want to running installs in products that are targets. Now, we're going to talk, we already talked about one of the issues, which has to do with a breach between hardware and the philosophy and hardware and the philosophy and IT about what constitutes, the architectural goal. Here we get into the second one, which is what are the capabilities of the underlying platforms. My friend Joe Weiss will point out that level 0 and level 1 devices are not secure. In fact, sensors are built with a backdoor. They're shipped to you with a backdoor built right in. Every sensor has a backdoor because that's how you calibrate it. And it's not, they don't even have like user ID admin, password admin, right? It's just hold down this button and you can tune whatever's going on. So that is a huge vulnerability. That's a place where zero trust breaks down. You cannot apply zero trust to a device that has a built-in backdoor. The things that are highlighted in blue here are the things that are zero trust. OT and IT perimeter, establish boundaries, segment as much as possible. Shield and monitor endpoints that cannot be patched or repaired. You want to isolate them, air gap as much as possible. Interesting piece that said in a world where we're using cloud services, where people are carrying cell phones all over the place, there is no such thing as an air gap any longer. And just be aware of the fact that the device in your pocket has about 6 or 7 EM bands, not to mention geospatial information, temperature, pressure, motion, and sound and visible information. There's a lot of capability in these things. They can break all sorts of stuff. And you heard recently Apple phones, you can hack the Bluetooth even when the power's off because the Bluetooth technology isn't powered off when you power it off. It still keeps running, so there's a persistent potential vulnerability there. Use network security adapted to industrial protocols. Now, there's two sides to that. If you're using raw industrial native protocols, Modbus was invented the same year that the ARPANET went live, 1969, right? So those are both equally old. It was in the 90s when Modbus over IP, I think that's 506, came into practice. People are using both. If you've got a pure hardware native Modbus environment, then you're going to want to use technology that's capable of reading those platforms on those connections. And there are vendors, Moxa comes to mind as one. If they're using Modbus over IP, then you can put IP rules. Many vendors of technology that can handle IP filtering and protocols have blocks for that. I think Trend's product has like 600 or 700 filters that look at the OT protocols. For offline operations, you want to handle the removable media very carefully, and that includes not just doing service and upgrade, but also disposal. Information can be brought off-site. And you want to bring this stuff together into a common platform. The CSIRT or SOC gives you a view of everything. And by consolidated console, I don't mean that everything shows up on one console. I have a client in New Jersey, and they get 1 million alerts a day. Right? Putting that on one console solves nothing. What you want to do is some integration, some correlation, some mapping, and you want to have intelligence from all of the platforms so you can filter out the wheat from the chaff. And instead of 1 million messages, you want 45 or 50, hey, this here looks like it could be a real nasty one, and you want something to go through there. Being able to be told how porous your attack surface is part of the solution, but you want to map that against what measures you've put in place. So you do not need to worry about this, that, or the other. I've got a spare tire. I know the pressure is low, but I've got a spare tire. You don't need an alert about low pressure every 15 milliseconds from your car's systems. So what kinds of mitigations can be brought? Well, this mystic chart from Clarity. Great report from Clarity came out end of last year on the first half of 2021. A banner year for ICT problems. And the biggest solution they have is segmentation. You don't want to let stuff propagate. Lateral movement is a big one. WannaCry traversed hospital systems in the operating room to get to platforms that it could mess with. Secure remote access. Who can have access to your system? I'm not going to get into a discussion about supply chain. We've got not a whole day to go through this. Supply chain security. Huge issue. It has to do with what parts are in what's coming to you, who made it, and what are the parts of the stuff you send downstream. Getting OT manufacturers to participate in that will be one of the requirements we lay out against them. I recommend this. By the way, for those of you that don't know Trend Micro, I've been there 5 years. Our CEO, Ava, was one of the founders 31 years ago. She makes the very strong point that the competition are the bad guys. If you are using somebody's anti-malware product, bravo, rock on, go with it. Okay? I want you to use something. So, you know, they can borrow from us. Clarity makes nice references to the zero-day initiative, and I will use industry sources, you know, with attribution where it's important to help get the message across. So, what do we want from the ICS vendors? First thing, it's hard. It's hard because some of these systems can't be patched or patchable. My favorite industrial IoT device is Voyager 1. It's 15 billion miles away. It's been running for about 42 years. And if you want to set up an SSL handshake, it'll take you a week because it takes 19 hours to get an EM signal to the satellite. And its 1/4 MIPS processor will generate a response that'll get back to you 19 hours later. So it's 6 days just to set up SSL. No host calls. When there was a shop across the street that said, we will deliver batteries. And I said, I'd like you to deliver a battery to the rover on Mars. And I said, no, we don't. We don't go off planet. The stuff's put in places you can't mess with it. You don't want some guy hanging on a power pole trying to, you know, do a local firmware update when there's a problem in transmission and distribution up in New Hampshire in the middle of winter. There's no AV on these things, and the reason is because they do not have the horsepower to run it. Cheap. You want many of these devices. You don't want them to be costly, so putting in co-processors means it adds expense, which raises a question that I'll probably hit again. Somebody says, why don't we use the federal government's buying power to incentivize vendors to make products that are, you know, provided with that? Well, any of you that have worked in a vendor knows that if a federal government requirement comes out for an additional capability without which you can't bid a federal contract, what do? You create a new SKU, right? So you got the general public one, and then you got the, you know, use this for federal government procurement. If the federal government had said, we're only going to buy vehicles with seat belts, then you'd have seat belts in the Abrams tank, you'd have seat belts in the F-35, you'd have seat belts on U.S. postal vehicles, but you wouldn't have seat belts on consumer cars. No, the solution is regulation. You cannot sell a car here unless it has seat belts and crash-safe bumpers and some kind of protection inside, airbags. Hard to get to the facilities to install the thing. Once they're out there, it's easy for the bad guys to get to the facilities. Difficult, complex environments. Most IT equipment is somewhat fragile. It's not comfortable in rooms where we'd not be comfortable. Doesn't work for ICT. The missing, it's not even on my slide. The missing problem is philosophy. The problem is the fact that the people who do industrial security have a different set of guiding principles than the people who do IT security. And the fact that it's deployed worldwide, the reach and range, and you sometimes have to go to the individuals. Now, when I'm looking at requirements, this is a chart from ARM. It's talking about their new capabilities, and this is a really cool processor. The stuff in blue to the top left, that's the processor that runs what you bought the chip to do. The stuff in orange is the capability to handle security. So this chip can not only, you know, tell you about what's going on with the sensor, what's going on in the pressure vessel, but it can also decrypt a message. It can also generate and respond to a digital signature. It can also support complex authentication, and it can allow you to do secure updates. It would be nice if people decided to use this. It'd be nice if the federal government said we'll only buy stuff like this, but the only way that the vendors are going to make stuff with this for everybody is if it is a regulation that says that has to happen. So that's a challenge. The organizational silos problem is significant, and I suggest that the thing you do is if you have both IT and OT operations and you have security issues, take a manager from your OT operations group and put them in charge of a department in IT for 6 months and vice versa. Rotational assignments. Take somebody out of this side, put them on that side, have them swap, have them stay in touch, have them talk for 6 months, and at the end of it, you'll begin a conversation, which can only make things better. Remember, if everybody's thinking the same, Ben Franklin said, nobody's thinking very much. So you need to be able to break down organizational barriers, and the best way to do that is with where you are sitting. So see how you can get these different people to start talking to each other. Another resolution that we see is the enriched, called it extended detection and response, where we are using automated correlation, where we're looking at telemetry and alerting, where we're building playbooks. Now, this allows me to talk for a moment about what we're doing with artificial intelligence here. AI has a role in detecting and trapping malware, but it is not the whole role. I believe that down the road, we will see an environment where about 5 to 10% of the defects you see are being caught by AI, and the rest are caught by more conventional, less expensive things. Here's an analogy. You got a problem with flies buzzing around the office. Well, you could hire 50 ninjas with fly swatters to run through the halls and swat flies. Effective but expensive. Or you could put screens on the windows and hire one ninja, right? More cost effective. You want to balance the amount of effort you're putting into it. A good piece of AI will not only detect the defect, but it will also generate the corresponding use case that goes into your automation capabilities. A good piece of AI that just finds defects is functioning at what we call a level 2 level of the capability maturity model. Anybody here not familiar with the capability maturity model? No hands, very quick. 2 questions. Question 1, do we have good documentation? If the answer is yes, you're level 3 or above. Question 2, if you don't have good documentation, does anybody know what's going on? If the answer is yes, you're level 2. If the answer is no, you're level 1. Right? If a problem happens and everybody downs pencils and runs around in a circle, that's level 1. If a problem happens and somebody says, oh my God, call Fred, he knows how to fix things with that, that's level 2. If the problem happens and you go to the documentation and say, oh, okay, we need to do this, vary this offline, start that, that's level 3. You want to get to level 3. The nice thing about being in level 3 is you get to go home at 5 o'clock to see your son's softball game and your daughter's ballet recital, or vice versa, whichever way works. The point is that AI should help you at a level 3 make its automation smarter so the cheaper, faster, less expensive thing gets done. And this will span classical IT, and it will also go into industrial control systems as well. So that's why I love playbooks, I love automation, and I love the addition of AI to that and monitoring. So, step-by-step guide to bringing it up. Map your data. Who's where? And the data is not just the information that you're going to be processing, it's also data like what applications are you running, where did they come from, what are they made of. Know your environment. Have a software asset management database. Software asset management databases can save you a lot of trouble. A few years ago, there was a report that there was a vulnerability in one of the Apache Foundation's products, a thing called struts. And you better patch it pretty quickly because folks can get in and mess with you. So folks said to their IT teams, are we using struts? We got to patch it right away. And at Experian, they said, are you using struts? And the IT organization came back and said, we're lucky, boss, we're not. They were wrong. They didn't know they were using struts, and they got hit. And that was the breach that took out 140 million IDs. Know what you've got. Validate it. Check it, make sure it's current. Work with your third-party suppliers. Ask them for a software bill of materials, the contents of what you got. You buy a can of soup, you look on the side, it says, it's got carrots, beans, pork, salt. You want to know what's in the software you got. And when you put something downstream, create a software bill of materials. You don't have to make up the form. There are standards about how these things should look, and there are tools about how to use them. Make sure you understand your network entry points and segment. Secure equipment, have a mitigation strategy, whether it's we're going to go to another location, think of it as an analogy to your business continuity plan, and implement a connected threat defense, and that means integration. So, what have we learned? Lots of vulnerabilities. Well. Yes. I want you to go back and take a look at what your network looks like now. Take a look at assumptions about air gaps. Long ago, I was at Gartner. I ran the Information Security Strategy Service during the 90s. Visited a client in this fair state, and they had a humongo database, huge mainframe DB2 installation, close to a gig in size. Now, remember, this was the 90s, and that was big then. And I said, so what backup recovery plan? He says, well, it's too large to back up. I said, so what's your backup recovery plan? Do you just roll forwards from checkpoint? No, our backup recovery plan is that this system is not allowed to fail. Groovy. Sell that. Make sure you understand what's going on with your level 0, level 1 systems. They cannot be protected. They're not smart enough to protect themselves. You just want to cut things. Take a look and consider out-of-band safety systems. One of the ways we were able to mess with the centrifuges in Iran was we fooled their safety systems into saying everything's fine, boss. Over the next 3 months, I want you to segment your networks. I want you to take a look at your supply chain, both hardware and software. I want you to know what kinds of stuff's coming in, where it's from. I want you to start swapping people between teams. I want you to make your organization smarter. Have you ever been in a meeting and asked yourself, how come 10 people with IQs above 120 can get into a room and have a collective IQ of 83? Right? Well, you got to be able to step into each other's moccasins and walk a bit. And over the next 6 months, secure coding practices, especially those robots, industrial control systems, they're getting software off shared repositories, just like your developers are off of GitHub. And if you think, Log4j was a problem, that got the press because a lot of it, but there might be something like that for the automation for an industrial robot that only has 10,000 customers and just as nasty, but every one of them is going to be hurting from it. I want you to develop an upgrade plan for OT, and I'd like you to write your congressman and ask them to legislate stronger regulation. So, as promised, here are the references. You can't read them, but you can print them if you get a copy. Happy to take any questions.
Thanks. That was a really interesting and insightful talk. So you did mention that bit about some processors starting to get more security features.
Yep.
Right. Industrial control system vendors don't build things out of a vacuum. They have suppliers.
Yeah.
Are they getting what they need to build more secure systems from their hardware and software suppliers? And if not, what are the gaps?
They do have them available. I gave a diagram from an ARM processor that was designed for industrial control systems. Intel has similar capabilities. Other chip vendors can do it. The problem isn't that they don't have supply. The problem is that they have no incentive to raise the price on the device from $5 to $8 in order to meet what they cannot identify as a market need. How many of your production environments ever rejected a product because it doesn't have robust security controls? It hasn't happened. That's why it's not a question of the market. Vendors will create separate SKUs to meet the federal government. It's a question of regulation, unfortunately. But thank you for the question. Yes?
I work for a healthcare organization, and right now the CISO doesn't seem to be aware of the whole section of technology that is right now not under his belt. It's OT. And it goes all the way up the line to a different vice president. So I was just wondering if you could speak a little bit more about how you've seen organizations break that cultural trust. I go out there and I'm not used to talking to guys in cargo pants and know how to make things that move and dials that spin, but it's been a real challenge, and all these things that I want to do, until I get the buy-off from the management program, it's difficult. Thank you.
I understand, and thank you for the question. That's a tough one. Sometimes the only answer is to get somebody from another time zone or at least another area code to come to your location with a business card that doesn't have your corporate logo and tell your boss what you've been telling them for the last 2 years. I worked at Cognizant, I worked at Optiv, worked at Gartner. Sometimes it's magic. But you reminded me of a story that I was going to tell, and I didn't because of time, and now I'm going to tell it because there's a hospital in New Jersey, and there's a ward that has 50 people in it, and the nurses walk the rounds, third shift. They check every patient every 30 to 40 minutes. And one of the nurses said, you know what? I'm taking care of my aunt at home. That's a New England aunt. And I got this thing off the internet. It only cost $50. It's a little pad. I put it under the mattress, and if she moves or if it detects water, you know, some kind of liquid, then it sets off an alarm on my phone, and I go up and I see if she's okay. And the nurses said, hey, that's kind of cool. Let's do that. So they went out, and for all 50 of these beds, they bought these devices. It was $60 a piece, maybe. So for $3,000, they instrumented every bed in the ward. And instead of walking rounds, the nurses could sit at the stations and handle intake and discharge and prescriptions and write up reports and all this stuff. And if an alarm went out, they were there right away. And guess what? The patients were happier. Patient care went up. The nurses were happy, and they were more productive. And they told that to other nurses in other wards. And within a year, every one of the 2,000 beds in this hospital had a $60 off the internet pad to notice if somebody were moving around or if there were liquid where there shouldn't be liquid. And it got kind of complex, so the head of nursing went to the CIO and said, could you manage these for us? And the CIO said, what the heck have you done? These things aren't FDA approved. Why didn't you just buy the beds that have that built in? And the head of nursing said, well, these things cost $60 a piece. And we bought them by the department. So we spent $120,000 over the last year, and nobody in procurement ever saw it. Those beds cost $8,000 a piece. I do not think the hospital is going to approve a $16 million capital acquisition to give us these beds. So could you please, you know, and it's Bluetooth, and it's not secure, and it is personal health information, and it's not FDA. So that's called shadow OT, folks, right? Shadow OT, and it's everywhere. When I was in college, I had a friend who was working with some folks at a naval aviation station, and one of the guys taped a radar detector to his rear stabilator. And whenever anybody got him in the crosshairs, he took off. And he was invulnerable. I mean, he was all over the place because he had this radar detector. So they asked him what his secret was. He said, well, I got this radar detector from Sharper Image or something I put on the back of the plane. And they said, well, we'll spec that out and let it out for bid. And you know, that $200 device now became a $200,000 component. There is shadow OT in every discipline. We use it all the time, right? And it breaks security. So, yeah, big problem. If there are any other questions? You have a question.
Hi, thank you, Bill. Great talk. Thank you so much. I was wondering, what do you see in the future, the coming years? What do you think the recommendations for securing control systems will change technologically, or organizations? What do you think is the biggest change going to be coming in the future?
Okay, well, thank you for that question. First, I do not believe that there is convergence. Convergence means the two things take over each other's functions. I'm never going to be filling out my IRS 1040 on an industrial robot, and I'm never going to use my phone to drive my car. They will remain separate. They have strengths. They are, however, increasingly interconnected. So the kinds of things that I think will happen are, first of all, more intelligence in the processors. Secondly, greater security on the connections. And I'm not talking about encryption. Encrypting the traffic on CAN bus is not the answer. It's authentication. It's making sure that the device is who it says it is, and the message it's saying makes sense. So it's logging and those kinds of capabilities. So yeah, regulation driving more intelligence to the processors, greater segmentation, more intelligence at endpoint devices to be able to trust that the message they're getting is a message they should pay attention to. We want to break man in the middle. We want to stop replay attacks, and that just requires a smidge more intelligence than what we've got so far. Thank you very much.